All right, now let's look at using completing the square to actually solve some quadratic problems. Now, I want to tell you that completing the square is a technique that will always work for you. However, sometimes it might not be the easiest technique to use. Sometimes it would be better to use regular factoring or use the quadratic formula. The times when this works well is if it's not factorable, but a is equal to 1 and b is even. And this is to avoid having to deal with fractions, because anytime you put fractions in the mix, adding and multiplying, dividing fractions, you're going to introduce some room for error just because you're not used to working with fractions frequently. All right, so let's go ahead and take a look at our first example, and I'm going to show you this technique. All right, so remember that in order to complete the square, we want to figure out a c value here that is going to have a relationship to the b value. Remember that c is b over 2 and then squared. Well, right now 7 is not, so I want to get rid of the 7 from this side of the equation by subtracting it and leave room to put a number in that is that relationship. So let's take a look at how that works. I'm going to write this as x squared minus 10x and then plus some number I'm going to calculate. That's going to be that new c value that I calculate. Now I'm going to have my 7 on the right hand side because I've subtracted it from both sides. And if I'm going to fill in that blank over there on the left-hand side, I'm going to have to fill in the blank here on the right-hand side with the exact same number. Because remember, if you do something to one side of the equation, you have to do it to the other side as well. So let's come over here to the side and figure out the number to put in the blank. The number to put in the blank is the c value that we're going to calculate, which is equal to the square root of b, or I'm sorry, the square of b over 2. So b over 2 squared, which in this case is negative 10 over 2 squared, or negative 5 squared, which is 25. You may eventually get to where you don't need to write all of this out on this side, but do it until you don't need it anymore. So I'm going to add 25 to both sides. Know that if I've added the same thing to both sides, I really haven't changed the equation. Okay, so now on the left-hand side, I have created a perfect square trinomial. So let's go ahead and write this in its factored form. So I know that I can write x and that the factor is going to be half of the b value, so minus 5, and I need to square that. So that takes care of this side. I've written it in factored form. Now on the other side, I simply need to do this addition. Negative 7 plus 25 is going to give me 18. At this point, I am at the point where I can take square roots to solve. I'm back to a simple solve by square roots problem. This will be plus or minus, and I can continue. Remember that the square and square root cancel, and x minus 5 is then equal to plus or minus the square root of 18. 18 isn't a perfect square, but we have a technique for finding perfect squares that are hidden. We can break this down into 9 and 2. 2 is a prime number. 9 could be further factored into 3 and 3, or you can just recognize that 9 is a perfect square. So if it's a perfect square, I can take the square root of it and bring it out of the square root symbol. So the perfect square, 9, can be rewritten as a 3 on the outside, and then we still have the square root of 2. So I'm going to replace plus or minus square root of 18 with that. So I have x minus 5 is equal to plus or minus 3 square root of 2. Finally, to solve for x, I want to add 5 to both sides so that I get x is equal to 5 plus or minus 3 square root of 2. I'd like you to try number 7 using this same technique of completing the square. Follow all of the steps just like I did and see how you did when you come back. All right, let's go through this real quick. So again, the first step is to move the current C value over to the other side so that we can put in a new C value that will make this a perfect square trinomial. So in the second step, I've done that and filled in my perfect square trinomial with the C value that I calculated. It was negative 18 over 2 squared, which gave me an 81. So I plugged in 81, and then I rewrote my perfect square trinomial as its binomial squared, remembering that negative 8 comes from taking half of the b term. Now I'm ready to take square roots, and I can say that the square root of x minus 9 squared is equal to plus or minus the square root of 76, and this cancels. That leaves me with x minus 9 on the left and plus or minus square root of 76 on the right. 76 is not a perfect square. However, I can look for perfect squares in 76, and when I break it down with a factor tree, I see that I have a pair of 2's that will make a perfect square. So the pair of 2's can be taken out as a single 2 because 2 times 2 is 4, and the square root of 4 is this 2 on the outside. Replacing square root of 76 with 2 square root of 19 here, I can then complete solving for x by adding 9 to both sides to move the negative 9 to the right, leaving me with x is equal to 9 plus or minus 2 square root of 19. All right, one last example before we move on because I want to show you a couple more things. One thing is sometimes it's not apparent that you have an a value of 1 to start with. Here I have 3x squared plus 12x plus 15, but I can create an a value of 1 by dividing everything by 3. So I want to divide all of these terms by 3. I'm also going to go ahead and divide the other side by 3. That way, instead of rewriting with the 3 on the outside, I've just completely eliminated it because I've divided both sides by 3. Rewriting this, again with a GCF that I divided out of 3, I have x squared plus 4x plus 5 is still equal to 0 because 0 divided by 3 is still 0. Now I'm ready to use my technique. X squared plus 4x plus some new c value is equal to negative 5 plus the new c value. C is going to be 4 over 2, remember it's b over 2 squared, which is equal to 2 squared, which is equal to 4. Again, if you don't need to write out all of those steps, that's fine. I'm just doing it so that you have it for reference in your notes. I want to add that 4 to both sides, and now I can rewrite this left side in its factored form. So I know I have an x and a plus 2 because I'm looking for half of the b number. On this other side, I can do the addition and get a negative 1, and I'm ready to take square roots. I'm going to take the square root of both sides, remember? And put your plus and minus on that side. The squared and square root cancel on this side, leaving me with x plus 2. And on the other side, I'm going to have plus or minus the square root of negative 1. We've got one of those pesky negative signs under the square root. Fortunately, we have a way to deal with that. Remember that a negative sign under a square root can be popped out as an I. And in this case, since it's the square root of negative 1, well, that's the very definition of I, square root of negative 1. So I can rewrite this as x plus 2 is equal to plus or minus I. If I'd had a different number here besides a 1, then I would have just dealt with that number and taken the positive square root of it, or at least simplified if I could. Finally, I want to subtract 2 from both sides so that I have x is equal to a negative 2 plus or minus I as my final answer.